Bem-vindos ao nosso espaço, um mergulho profundo nos assuntos mais interessantes de esportes, ciências e temas gerais do momento. Aqui você vai encontrar conteúdo de qualidade, com análises empolgantes e descobertas fascinantes que vão expandir seus horizontes. Nossa missão é trazer informação relevante de forma dinâmica e descontraída. Queremos que você faça parte dessa jornada incrível de conhecimento e diversão. Se gostar do nosso conteúdo, não esqueça de deixar seu like e se inscrever no canal para não perder nenhuma novidade. Ative o sininho também. Aproveite!
If you love science, don't forget to like and subscribe. Imagine trying to learn a language that hasn't been spoken aloud for over 40,000 years. We're not talking about Latin or ancient Greek. We're talking about the hypothesized sounds, syntax, and phonetic constraints of our closest ancient relatives, the Neanderthals. This isn't just a quirky thought experiment for linguists. It's a radical cognitive challenge known informally as the Neandertal Tongue Effect. The idea that attempting to learn these reconstructed, phonetically distinct languages fundamentally reshapes the architecture of the modern human brain. For decades, the dominant scientific view held that Neanderthals likely had sophisticated nonverbal communication, but their vocal capabilities were limited. However, modern research, analyzing the geometry of the Neanderthal hyoid bone and the size of the hypoglossal canal, which houses the nerve controlling the tongue, suggests they could speak, though likely with a much higher, harsher, and less efficient vocal range than modern Homo sapiens. If we assume a functional Neanderthal language existed, it would have been highly constrained. Modern human languages utilize a vast spectrum of vowel and consonant sounds, phonemes, that allow for incredible acoustic flexibility. The Neanderthal vocal tract, optimized for high energy intake and cold climates, might have restricted speech to only the most acoustically rugged sounds. Imagine a language built primarily on just 3 vowels, heavily guttural consonants, and rapid, short bursts of sound. This is where the Neandertal Tongue Effect begins. Our brains are hardwired for the complex, nuanced phonemes of our native language. When an adult tries to learn a standard second language, the brain maps new sounds onto existing neural structures. But what happens when the new language is so acoustically foreign, so radically simple yet physically demanding, that it forces the brain to create entirely new, non-standard neural pathways? Researchers who study cognitive plasticity have observed that immersion in these extreme reconstructed languages, whether Proto-Indo-European or hypothetical Neanderthal, forces the brain to allocate new cortical space. The primary auditory cortex, instead of relying on familiar patterns, has to build entirely new categories for sounds we naturally discarded tens of thousands of years ago. It's like forcing a high-definition processor to run only in blocky 8-bit mode. Crucially, the vocal and motor aspects are highly demanding. Reconstructing Neanderthal sounds requires extreme manipulation of the back of the tongue and throat, actions that modern language rarely demands. This intense motor effort activates specific regions of the motor cortex. And here's the fascinating link. As we mimic these sounds, our mirror neuron system, the foundation of empathy and understanding, is engaged, trying to map these primitive sounds back onto the conceptual world of an extinct hominid. Are we activating the same neural circuits Neanderthals used for social bonding and communication? Furthermore, there is the grammatical dimension. If Neanderthal communication relied on short, immediate utterances necessary for hunting and survival, their syntax might have lacked the abstract, recursive complexity we see in modern languages, the ability to embed clauses within clauses. Attempting to think in a drastically simplified syntax, stripped of hypotheticals and complex temporal markers, could temporarily shift how we process time, causality, and abstract thought. This challenges the sapir-whorf hypothesis, which suggests language dictates thought. If the Neandertal Tongue Effect is real, it's not just about learning new words. It's about shifting the very framework of conceptual organization, temporarily transporting the learner to a cognitive world defined by immediacy and essential communication. Studying the neurobiological impact of extinct languages is a powerful tool for understanding the ultimate flexibility of the human brain. It shows us that our cognitive capacity isn't fixed, It's a dynamic system capable of adapting even to the linguistic ghosts of the Pleistocene era. By reaching back into our linguistic deep past, we are fundamentally altering our present cognitive wiring. For more incredible facts like this, don't forget to subscribe and turn on notifications.